Another interesting insight into the data is if we look into the table, essentially it shows events executed by strategy, by a given strategy here, which are not executed by strategy in blue. Okay? So what I would like to highlight here is this first number, 1,000 events, which are executed by the users, but not exercised by Monkey Lab in interactive mode. So what you can see here is that there are still some transitions or events which were not observed in our traces, which we simply didn't put in the test case. And as I said, this is a matter of parameterizing our approach, because if we created obviously longer test cases or more test cases, we could obviously cover some of these events. But what is even more interesting is that Monkey Lab is able to generate meaningful transitions which were not observed in actual executions, right? So we are able to augment successfully these test cases with events which were not observed in real executions, and they are feasible test cases. So obviously we also evaluate whether these generated test cases represent natural usages. So this is just one of those examples. This is a GNU Cache application. In this case, this is fully lemmatically generated Monkey Lab test case. What you can see here, it is a meaningful sequence of steps. So basically, we're trying to create accounts, we're looking into different accounts, etc. So, and if you're interested to see more cases, just refer to our online appendix. Now, where do we go from here? As I mentioned, there is this really cool smartphone testing farm framework, which is open source. We've currently actually extended this framework, so you can see the tab here. It's called Event Collection. This is our work. What we're trying to do here, we're trying to enable remote collection of these low-level events through the web interface. So the idea here is we would like to crowdsource this process to people who don't have real devices. So in other words, all we have to do is just to give you the link to the website, to all of you, to use this application. You'll just log in on that website, and we will collect all the data while you use that particular application. So this is pretty cool because we actually don't need to give the actual device to ask it to send the data from the real device. This is another prototype which we call Record Multi-Platform Replay. This is done in collaboration with a major telecommunication company, Huawei. We met them when Mauro was telling his story. Our story was very similar to Mauro's. They approached us at Dixie last year, and this is one of the reasons why I did not regret publishing our paper at MSR, because they approached us at Dixie and they said, "We saw your MSR paper on Monkey Lab, and we're really interested in that. And imagine if we did not publish our paper at MSR. Now we would basically miss this great opportunity talking to these guys." And similar to Mauro, they said, "We really like what you're doing. We'd like to come and see you at Lumiere." This is what they did. They came to visit us for a couple of days. And they like many other things we've done, not only this one, but also they like Gemma, and I'll talk about that in a second, in a few minutes. But one of the big problems that they have is obviously to be able to test the application on multiple devices, right? So while this solution is not tapping into crowdsourced data collection, basically what the solution does is it does record the test case in one device, it translates it, and then it replaces it on some other device. So let me show you a quick demo. In this case, we are recording a Nexus 7 tablet. This is just a typical use case for YouTube application. So now we are doing translation step. So we are abstracting to the very sequence level. And now you will see that we're going to replay this application on Huawei made as phone. You can imagine they gave us the phone. And now we are replaying that in landscape mode for that particular scenario. And now we're going to do the same thing in portrait mode. So this is one demo, and there is a lot of work that goes right now for some of these tools and trying to actually put them into practice. But now let me shift gears here and talk about something else. Many of you probably ran into the situation many times before. Actually, Mauro also told us about an interesting case about updating his WhatsApp before meeting somebody at the airport, right? I've also ran into that situation, by the way, but not with WhatsApp, but some other application. When I really needed it, it's like I reinstalled update, and now I needed to enter my password, which of course I don't remember. And I could use it when I really needed it. But what do we usually do in this case? What do you usually do when you run into this case?
Shut down the phone.
Okay. I didn't expect you to answer.
I know.
Stop the application.
Stop the application. Try again. Okay. What if it's the same thing?
Get another application.
Get another application. In fact, this is what 50% of the users do, according to Google marketing research. Okay. You don't like something, you just uninstall it and you get another application, similar application. And there are plenty of similar applications, right? But why is it important? Well, if you're an application developer, and if you have a problem like that, and if this problem is due to somebody else's API, you're not happy about the situation, right? Because you stop making money on this application because your users switch to some other application. So it's important for us to address these kind of problems very, very fast. But in order to address these kind of problems, we, of course, need to be able to reproduce these problems, right? And if you ever looked into bug reports, and in particular bug reports for mobile applications, you will see that those bug reports have many problems when it comes to reproducibility, right? Imagine explaining complex gestures in natural language, right? So obviously, this is a very big problem. However, we need prompt resolution of bug reports, and it is extremely important for application success. Of course, we have all these nice mechanisms, like user reviews. We talked a little bit about it. Great. We also have these bug tracking systems. We all use them either in the context of our classes or open source development. However, of course, there are other solutions like in-field failure reproduction. And again, the idea here is we have an application. As some of you said, we can instrument that application, right? And then we can put that application in the field, and we can fully instrument it, partially instrument it. And then when we get an error, we can send all this information to developers that can do diagnosis of this failure and hopefully fix it if we have enough information. And obviously the trade-off, how much of the application we instrument to provide sufficient information, but at the same time not to introduce significant overhead. And there are many commercial solutions which I implement for this type of problem. However, as I said, it requires expensive instrumentation and may not necessarily be suitable for model context. Of course, with extreme resources. We obviously need oracles in order to capture and reproduce failures in the field, unless those are crashes. Then we get those oracles easily by default. And may not be easily adaptable to event-driven and fragmented nature of mobile applications, right? And of course, when it comes to bug reports, we have a very famous problem. And this is a lexical gap between reporters and developers, right? Reporters don't know anything about the internals of the application. And this is amplified in typical user reviews that you can go and read out there. They don't know anything about the internals, right? They don't know what is the class behind that widget in the class, right? Or they just tell you the application crashed because of that weird window, right? And you don't know which class implements that weird window, right? And of course, developers have intimate code knowledge of this application. And in many cases, when we get reports that we don't understand or cannot reproduce, we just say works for me, we quickly close the bug report just to wait for it to be reopened 5 minutes later because that bug is not done, it's still in our application. So reproducibility is a very, very important problem, a challenging problem, right? Because we get these bug reports in natural language, ambiguous, with all the complexity of modern apps, we're getting lots of non-reproducible bug reports. In fact, there has been several really good studies on how to write bug reports and what we need in those bug reports. I put some of these papers at the bottom. And of course, insufficient information is one of the major reasons why we get non-reproducible bug reports. And according to these studies, in order to help in this situation, we need steps to reproduce, obviously. We need stack traces because they can be very helpful to identify where the problem is. And of course, test cases scenarios are considered to be most useful sources of information when it comes to reproducing bug reports. And what is even more important, we need this information early in the bug's life cycle, right? So we don't want to go through 100 instances of different duplicate bug reports, which are written in slightly different language, referring to exactly the same bugs, and half of them is not reproducible. This is maintenance nightmare, right? However, what most of the research has done up to this point is basically say we're going to get this bug report and we're going to do something about it. We're going to accept reality as it is. People are going to use these bug tracker system, right? Bug tracking system, user use. They're gonna still write these kind of bug reports. Yes, maybe we'll give them some kind of guidelines on how to write these bug reports. Like you can find pretty good guidelines on Google how to submit bug reports, which will tell you exactly the same things: text to reproduce, test scenarios, and stack traces. However, in this particular project, we took a completely different take on the problem. We said we're not gonna wait until your bug report makes it into bug tracking system. We're going to fix the way bug reporting is done, and hopefully we will be able to complete your bug report with pertinent information. I apologize for these interruptions. Obviously, that was not part of my testing, so these bugs are completely new to me, and they are non-deterministic. So I cannot reproduce them in some cases. But we're going to deal with that. So, our take on the problem is the following. We're not going to wait until we submit this bug report. Thank you. So the patch is coming. Thank you. Well, thank you very much.
It's last one, sorry.
So now you can enjoy this nice picture. And I'll show you even better pictures in a moment. But as you can see, the primary idea here is that we are going to analyze this application beforehand. We're going to run some static analysis and dynamic analysis in this application. And we're going to build an approach that will help the users to autocomplete this information with the knowledge of this application. So the idea here is our approach will try to understand where you are in the application at any given moment in time. In other words, which state, which particular release state you are in. And given that knowledge, we will know which other possible transitions, which transitions are possible at that moment in time, and we are going to recommend you those transitions. And if you agree with one of those transitions, meaning that that's exactly where you want it to go, we're going to automatically complete that step to reproduce and generate it fully automatically for you as part of the bug report. As part of this really nice looking bug report. which I will show you in details in a moment. And we're going to give the bug report to the programmers. So the idea here is there is very minimal input that we want from you as a user, but we will know all the details that you're technically not supposed to know. You don't need to know. You interact with this application as a black box. You click on that OK button, you send that email, but when we know that you're doing this particular action from that particular state, we will provide developers all the low-level information about classes you're interacting with, as well as what you do at that moment in time. So from developer point of view, they're not only going to get natural language report saying what they're doing, but they will also get all the information about the code, where those steps to reproduce are happening in the code. And the assumption here is that it will be more useful for developers than some ambiguous bug report of natural language that we cannot parse. So the underlying idea here is that we are relying on static analysis to identify all the objects, and transitions. And we're also relying on dynamic analysis to read the application. Here, by the way, you can imagine that if we have data from real usages, we can easily generate these test cases by relying on language models from the previous part of the problem. And once we glean this model, it's part of the Fusion database that our auto-completion engine is going to use while interacting with the users. So this is just an example of the kind of information we get with the UI estimator. This is, in this particular case, we get the snapshot of the UI hierarchy of this particular application. So we know that at that particular moment in time we clicked on the settings menu. And we get all the information about what happened at that moment in time, activity, state that particular group component was, and type of action. And more importantly, we also get the screenshot, or we grab the screenshot of that particular component that you interacted with. And I'll show you why it's important in the authentication slide. So, let me show you now an example of submitting a real bug report with Fusion. So in the first part, we do exactly the same thing as you would do in any bug tracking system. We fill in the header. In this case, we need to specify the device we're trying to reproduce a bug, orientation of the device, title for the bug report, and some brief notes. And this is where the magic starts. Here, we are trying to reproduce a step number 1. So we're starting from the topmost GUI state of this application. And this is a form that we ask basically developer or user to fill in. So in this case, it says I, and then type of action, that in this case they can choose. And they can choose the component that is available at that particular GUI state that they can go to. In this particular case, they choose one of the components, which has been added. And once they preview the step, they add the step to reproduce to the bug report. So step 1 is added. Basically it sounds like this. We clicked on relative layout. Okay? So this is actually the name of the class. Located at the top left. And component is located in this particular activity. Here is the component image. And also we provide the exact location of that component on the screen. So this is as much as information as you probably need to unambiguously know exactly where to click and what to do to reproduce that step. If we're missing something, please let us know. So this is the second step. In this case, we add another step where we click on text view located at the top. This is a location of this component in this particular activity. This is a component image. Then we do this for all the other steps, which will get us eventually to the bug. And in this case, we have 7 steps. And this is our final bug report, okay? Which looks like this, which has 7 steps, detailed natural language descriptions, including component the source code responsible for these actions. Screenshots, what we did with the application, summary of all the steps. And on top of this, if we are able to recognize all the GUI states that we need, we can fully replay. We just press button, and you get fully replayed text. What do we do in those cases where we could not recognize GUI state that you're in? Because it's a legitimate scenario, right? For example, we get a new state because of the data, like with our to-do list example, right? We have more items in the list, we will have more states in the application. What do we do in that case where we cannot recognize that particular state? In that case, we ask the user to fill in the step to reproduce themselves. So the idea here, at some point, we may lose the user. So we may say, we don't know which state you're in. The user cannot recognize that state. However, at some point, we're hoping that we're going to back to the state that we recognize in our flow. So in that case, we will start auto-completing the steps again. Of course, in that case, you're not going to get fully reproducible bug report, but you will get partially reproducible bug report. Now, empirical evaluation. I will have a question later on for everybody involved. But the major question that I will ask is, how can we improve this evaluation? And there is one very obvious way how this evaluation can be improved. I really like examples from Rocco because he sort of debugged what happens with the paper, what comes back, what you needed to do. This was a conference, in and out. It was in. But it doesn't mean that this evaluation cannot be improved. And hopefully you'll be able to spot this, and hopefully you'll be able to think a little bit more together. Because these are sort of things that you will be responsible in your research. You will be not only designing tools, building tools, but also evaluating them, right? And then you will need to be fighting reviewers at some point in time who will not be happy with this evaluation and thinking how you can improve it, how you can do more. So in this case, we've done an empirical study with involving 2 software maintenance tasks and 2 questions that we were interested in. Obviously, the first one, we need to create bug reports, right? So the first question is how easy it is to create bug reports, and how easy it is to create bug report, and how, when you compare it to, for example, Google Issue Tracker, right? Because you can create also, does it take more time? Does it take less time? Is it easier to use? Is it harder to use? Fairly obvious questions. However, more important question is, once you create those bug reports, are they more reproducible than reports which are created with Google Code Issue Tracker? Or maybe are they more reproducible than original bug reports? These are important questions that we really need to answer, right? So in order to do that, we sampled 15 real-world Android application bugs. And we designed 2 studies to create bug reports and reproduce those bug reports with users using different settings. And I'll show you that in a second. So these are 15 Android applications and bugs that we used in this study. You can notice that we have different types of bugs here. We have not only GUI display errors, we have also crashes, data input calculation errors, navigation errors. If you want to get original bug reports for these applications, just go to this repo for this app, and you'll be able to find this bug using this ID. This is a number of steps, minimum number of steps, which is required to reproduce this bug. Obviously, there are many other ways how you can reproduce this bug, because of different paths, but this is the minimum number of steps that we were able to reproduce these. This specifies the type of the bug. And this is basically the depth first search activity coverage. So this basically tells you the number of activities we're able to cover with systematic exploration for that particular application. Basically, just giving you some indication how easy it is to systematically explore this application. So during each study, we collected detailed information, including time that it took users to create and reproduce the bug. We also collected extensive feedback on the experience using the tool. Also collected users' preferences using each type of bug reporting system, and of course, recorded the experience of the user. And this was very important for us, because we wanted to know whether this type of bug tracking system would be useful not only for developers, but also for inexperienced programmers, right? So these are some of the questions that we asked. And major research questions are whether it's easy to use, what are the information preferences, how reproducible these reports are as compared to other bug tracking systems, and how fast they can be reproduced. So for the first task, or for the first study, we involved basically 8 students, graduate students and undergraduate students, and we exposed these users to the bugs by showing them the videos of these bugs. And basically, all these participants reproduced bugs on Google Nexus 7 tablets with Android 4.4.3. These are basically some of the results for some of the time results for reproducing these bugs. And here, important thing to notice is we have participants who are experienced participants and also inexperienced participants. So what you can see immediately here, these are the results of Fusion, that for this guy, it took him on average slightly more to create the bug. This is not reproduce, but create the bug. But on average, it took approximately the same amount of time for inexperienced people to report the bug as compared to unexperienced to compare experienced people. And these are some of the answers that we obtained from the user on the usability of the system, or what other features they would prefer to have. But one interesting study is the second one, where we really wanted to know whether these bugs are more reproducible or more frequently reproducible, and whether this comes at any price. So in this case, we enlisted 20 participants. All of them are computer science graduate students. And as a result of the first study, we had 135 bug reports because those 8 people created also bug reports not only using Fusion, but also Google issue tracker. And we also took original bug reports from the bug tracking system. And the idea was to evaluate all these bug reports with 20 participants. And the goal, they were given Nexus 7 tablets. They were given bug reports. They didn't know which bug report was original bug report, which bug report was submitted with Google issue tracker, and which bug report was submitted with Fusion. They just needed to reproduce it, and we basically checked whether they were able to reproduce it or not, and how much time it took them to reproduce it. Okay. So these are the results that we got for reproducibility. Essentially, here you see that these are the results for Fusion for experienced, and here we're going to report number of bugs that we were not able to reproduce. Okay, and this is Fusion inexperienced. This is a Google Code experienced, and this is Google Code inexperienced. What this means is that these reports were created by using Fusion by experienced programmers, and these reports were created by inexperienced programmers using Fusion. And the same experienced and inexperienced by using Google Code. And these are original bug reports. Okay? And this is a number of bug reports that we were not able to reproduce. Okay? So what you can immediately spot here is that with Google Code we had much more bug reports that we were not able to reproduce due to some ambiguity or missing steps to reproduce, or some other missing information. And of course, we also had some bug reports which were not able to reproduce, which were original bug reports. So in total, for Fusion, we had 13 bug reports which were not able to reproduce, and we had 23 bug reports which were not able to reproduce for Google Code total. Okay? So this is pretty good, right? Because we are able to reproduce bug reports, but what is even more important, we're able to reproduce bug reports which come not only from experienced people, but also bug reports which are coming from inexperienced people. This is really important for us, right? Because we want to make sure we're improving bug reporting mechanism not only for developers, but also for end users. However, there is a price to pay, obviously, because it takes a little bit more time to reproduce bug reports with Fusion as compared to bug reports which are written in Google code for these reasons. But Fusion bug reports are longer, right? So it takes more time to read the steps and to reproduce the bug report. So here, approximately time to reproduce Fusion reports is approximately 1 minute longer as compared to Google issue tracker. Of course, the obvious point of improvement here is to try to minimize the number of steps. This is currently something that we're currently working on. Because technically speaking, once you submit the bug report, there may be another way to get to this bug with a fewer number of steps. But of course, there are challenges. So now, let me get to my question is, how can we improve this evaluation? Did this evaluation convince you that this is really useful for developers? Do you see anything missing? Everybody but empirical software engineering groups.
Maybe your small participants.
Participants, okay, sure. That's something that Rocco pointed out. To a certain degree, we were lucky. Well, we got some of those comments, but reviewers basically said this is so great and novel that we're gonna overlook some of the issues we had in the study. These are summary of the comments.
Bug fixing is really useful during bug fixing.
Well, Rocco, everybody, but
Yes,
that's exactly
but the description probably is longer than the original probably. Is the data is really useful or not?
Exactly. I mean, the most important question here is also, yes, we can reproduce the bug reports more often, which is great. We see some evidence. But even more important question, are these bug reports providing us with information that can help us to fix this bug? Right? So this is not useful. But again, as I said, we were really lucky that reviewers overlooked some imperfections in our study and really pointed out the novelty of this tool. What also helped us quite a bit in this case is that we had a real tool available on the website, and we had full replication package for our study. So basically, everything from the paper was available for reviewers. We had running tool that they could log in and check, and we had all the data from the study. And this is something that you can check for yourself, which is available on fusionandroid.com. Now let me show you a couple of really cool things. This is, as you can understand, Fusion is just one step. But what is the goal? What is the big goal here? The big goal here is to have a bug tracking system. So this is something that we developed with my undergraduate students in the spring semester. We actually made the first crack on the bug tracking system, which revolves around Fusion. So here you see many APKs which exist in our bug tracking system. So here we have different types of issues, and I'll show you in a second the reporting mechanism. Yeah, so basically you're able to submit the bug report, and when you submit the bug report, you pretty much get the same interface where you can pick available states at that moment in time. And what is even cooler is in this particular implementation, that's a set of steps that you have to complete. What is even cool about this implementation is that in this case we're not relying on the automator, but we're relying on Android accessibility services to do the ripping of the code. But anyway, this is what we currently have. Now, there are lots of these tools, right? And I already talked a little bit about these tools. And these tools help us in testing these applications, but there are obviously a number of limitations. And from the developer's perspective, and by the way, this is one of the papers which I highly recommend you to read, which is AC 2015. This paper basically points out that some of these tools are indeed very useful, but they lack detailed, easy to understand testing results of faults and crashes. And using information which is produced by these tools, it's very hard to reproduce these test scenarios. And many of these tools are considered simply non-practical from developers' point of view. Moreover, many crashes may be mapped to well-defined externally inducible faults. And when it comes to mobile applications, pretty much there are no tools that allow testing for contextual events, such as network connectivity, screen rotation, or account for many other externally inducible faults. And many of these faults are dominant truth quotas behind many of the crashes that we see in the field. So one solution that we have to this problem we titled as CrashScope, and we came up with a completely automated approach which helps you to detect crashes in the running application, and then give you fully reproducible natural language bug report, similar to Fusion, that summarizes a set of steps that you need to take to get to that particular crash. Again, this solution requires no specification. You don't need to do modification to the applications or to the operating system. It's capable of running on both physical devices and emulators. And what is even more important, we enable testing for various contextual features, such as sensors, Wi-Fi, GPS, and orientation on the screen. Similarly to Fusion, it's also based on static analysis and dynamic analysis. And again, this part, if we have actual usage of the application from the field, we can generate these test cases by relying on language models. In this particular work, we are relying on systematic exploration of the application. And the idea here is we explore this application using static and dynamic analysis. Once we encounter the crash, we generate the report, and we produce fully reproducible test case for that particular crash. These are some of the details behind our approach. And just to give you a few ideas of what we're able to do with CrashScope, we have different strategies that we designed to traverse applications. Of course, we can traverse them in top-down and bottom-up fashion. We can also handle the text, and we are doing also contextual features with random inputs, and we also enabling and disabling some of the contextual features. But let me quickly explain just how we are able to identify where some of the contextual features are used inside of the application. Basically, we are relying on API calls for those particular sensors. And here we're relying on callbacks to identify, basically backpropagate to activity where that particular API call for that particular sensor is used. So if we know that that sensor is used in that particular activity, then we enable or disable that particular service within that activity. If we're not able to trace a particular API to that activity, but we know that that API is used in the application, that we enable or disable the service at application level. So let me show you the real demo. This is CrashScope running on a new cache application. Again, you can notice here that this is systematic exploration, not as natural as you saw in the example in MonkeyLog. And as you will see, sooner or later it will find the crash that we are after. It will take CrashScope just 27 steps to find the crash. This crash will be due to the incorrect input. We were putting some input that we were not handling for that particular field. So here's the crash. So what does CrashScope do? It generates this beautiful crash report, which basically summarizes all the steps that you need to take to get to the crash in natural language, as well as it summarizes all the contextual features that were enabled or disabled in that particular execution step. So here, we say, for example, you tap on expenses, check fuel, which is located in the center of the screen. We also crop that particular component that you need to interact with at that particular step. And we provide this information for every single step in the crash report. So in this case, you see that we have 27 steps. You also get an overview of all the steps. You get stack trace. And CrashScope is not a toy application. This is Actually, let me show you the demo. So you log in into Crushscope, you have multiple APKs. So you can upload another APK for analysis, you can indicate the particular strategy you want to explore this application with. Or you can just let Crushscope basically execute all these strategies. So here you can see that we already ran Crushscope on these three APKs. Now we found 3 bugs, 3 crashes for that particular APK. So you click on that particular crash report, and we get our extensive, nice-looking crash report, which specifies all 27 steps in this case to get to that crash with all the screenshots, all the states, stack traces, and this is an example of another crash report, which is fairly easy, just 2 steps to crash the application. Okay. So this is Crushscope. This is application that we're also currently evaluating with Huawei. We're running this on 500 APKs that they currently give us. The idea here is before trying to adopt this, they have a competitive project that also discovers crashes, but they don't have a project that summarizes these crashes in natural language bug report. Basically, what they said for us to seriously look into this, you need to convince us that you're able to identify crashes that we're not able to identify. So right now, we're working on some iterative improvements, trying to find crashes that we cannot find on that set of applications. So how did we evaluate Crushscope? In this case, evaluation was a little bit more extensive because in that AC paper that I showed you, they provide a benchmark, nice benchmark of Android applications, and they also give you all the tools, several tools that they were able to run on that benchmark. So they give you virtual machines. So technically, if you're in this field, you will be able to download that virtual machine and rerun results of the experiments. Although from our own experience, reproducibility here is a big issue, and there are several different reasons that I'll try to cover in the end, but when you're trying to do large-scale execution and you run multiple instances, you do have several different technical problems that in that case you don't get exactly the results that they're getting in the benchmark, but we did 2 studies here. We compared Crushscope against these 5 state-of-the-art tools: Dynadroid, Monkey, Puma, GUI Ripper. All these tools run in the virtual machine, which is provided in the AC paper. We evaluated these tools and compared them to Crushscope on all these 61 Android applications, and the idea here was to measure number of uncovered crashes. So this list of applications goes beyond the slide, 61 applications here, right? But these are the results for different tools. This is Crushscope, and these are other tools. So here you see 2 results. One result is here, number of crashes, total number of crashes across all these APKs. And in parentheses, you see number of crashes which are not due to the bugs in the application, but crashes which are due to instrumentation problems, because they also were measuring coverage, and all these crashes actually due to instrumentation of this application, not due to the bugs in the application. So basically, all these, besides Puma, has crashes which are due to instrumentation coverage. Obviously, we don't get any crashes to that, but interesting point here to see is we do get some orthogonal crashes which are not detected by other tools with Crushscope. And obviously, on top of that, none of these tools is giving you interpretable results, but we're giving natural language crash report, detailing all the steps with all the details how to get to the crash, which is, by the way, fully replayable. So now, the important question, which is similar to Fusion, is we do generate these crash reports, and we do find crashes which other tools don't find. But what do users think about these crashes, the crash reports? So we again enlisted here graduate students, 8 real-world open source application crashes, and here we wanted to evaluate readability and reproducibility. So some of you may be smiling, just 16 students, just 8 real-world open source application crashes, but it is a lot of work. It is a lot of work. So some of you who will start doing similar user studies will understand that this is a lot of work even on such a scale. Okay? And Roka can tell you a little bit more about it, but if you're trying to do more, it is very expensive. It is very difficult to enlist people. It is very difficult to design studies. It is difficult to run them. Basically, the outcome of the study is our crash reports were as reproducible as our crash reports, because we also wanted to compare it to original crash reports. But more importantly, basically users thought that our crash reports were much more readable as original crash reports for these reasons, because we provide all the detailed information. So any questions for now? We have approximately 40 minutes, which is great, because that's exactly enough time for me to cover one more pretty cool application. And then we will jump into the execution engine infrastructure. I will actually show you the details behind all the hard work which is actually necessary to run these tools. Because it seems like these are just prototypes, but they are running on the real infrastructure, which took us a lot of effort to develop. When we were developing this infrastructure, we actually ran into lots of issues which are not documented on Stack Overflow, or you cannot find it in Google documentation. We also found lots of problems that we had to modify in Android SDK because there were bugs in order to be able to, for example, enable large-scale analysis and execution of these tools. And I will basically point out some of those essential and accidental challenges, as we would like to call them, in the final remarks. And I'll explain